Hello everyone. Did you know that renewable energy is becoming an increasingly important part of how we generate electricity? But generating clean energy is also part of the challenge. We also need to make sure that electricity is available when and where it is needed. Renewable sources such as solar, hydro, and wind are variable, meaning they depend on the weather condition, such as the sunlight, the wind, and electricity demands continues to fluctuate. This creates a fundamental engineering problem. Sometimes we have more renewable electricity than we need, while at other times, renewable generation may not be enough to meet the demand. So, the question becomes, how do we manage the gap? Noki, what can you share about storing electricity?
Thanks, Jomil. Yes, we can use that surplus to cover the gap later, but we need to see how long do we store it for and what kind of systems do we use. So we have two kinds of systems over here. We have lithium ion, we have iron air. Lithium ion is great for hours, but cloudy week or winter time isn't hours, it's days. So to expand lithium ion for that kind of usage is very expensive. As we can see over here, it costs 10 cents per kilogram for iron, where it costs 9 cents per kilogram, sorry, $9 per kilogram for lithium carbonate. So that's why iron air is being used for the long haul. And iron air works very simply. It's reverse oxidation, which is iron rust, but the other way. And and its capacity, it could be up to 100 hours, which is capacity over power. Uh, but it's very but the problem is it's less efficient and it's bulkier. But it shouldn't be the complete replacement for lithium ion, but it could complement it. Lithium ion could be used for the short bursts, where iron air could be for the long-term storage. But as long as it's stored, it needs to reach to people. Over to Michael.
Thank you, Noki. Hello, everyone. My name is Michael Alleyne, and I will explain how the smart distribution system ties the different parts of our proposed solution together. The system connects renewable generation, energy storage, the main electricity grid, and electricity consumers. Unlike a traditional grid, it allows two-way power flow, meaning that homes, businesses with rooftop solar, batteries, or electric vehicles can both use electricity and return excess power back to the grid. It continuously collects information about electricity demand, renewable production, weather conditions, grid limits, and available storage in different technologies. And an AI smart grid controller then uses this information to decide where the electricity should go. When solar or wind produces excess electricity, it can be stored in batteries, thermal storage, pumped hydro, or transferred to another region that really needs it. And when the demand increases or renewable output falls, that stored energy can be released to support homes, hospitals, schools, businesses, and electric vehicle charging. Thank you. I will pass it over to Oscar.
While we demonstrate how hybrid energy storage portfolio provides the raw capacity Ontario needs, physical hardware alone cannot solve the grid load inertia vulnerabilities. As fossil fuel turbines are phased out, we lose the physical rotation node inertia that naturally stabilizes grid frequency and voltage. When cloud cover suddenly drops solar output, voltage fluctuates in milliseconds. Traditional centralized bi-level optimization takes anywhere from 15 seconds to 5 minutes to compute new set point. Is far too slow to prevent voltage collapse or equipment trips. To bridge this gap, I introduced a smart software solution, multi-agent deep reinforcement learning using the twin delay DDPG DT-free algorithm. Instead of relying on one central cloud server, We place tiny AI model directly onto local hardwares, like smart inverters. These local devices talk to each other and fix power levels in under 15 milliseconds. This cut central computer's load by 85% and keep the grid voltage completely stable.
Thanks, Oscar. As we've seen, artificial intelligence is already improving the way renewable energy systems are managed. It helps monitor power generation, predict electricity demand, and optimize how energy is stored and distributed. However, this is only the beginning. Looking ahead, future AI systems will even become more autonomous and capable of making real-time decisions across entire energy networks. Instead of simply reacting to changes, AI will be able to anticipate equipment failures, predict weather conditions that affect renewable energy generation. We can also expect AI to work alongside emerging technologies such as digital twins, IoT sensors, and advanced robotics. Together, they will create intelligent infrastructure that continuously learns, adapts, and improves system performance with minimal human intervention. Ultimately, AI is more than just another technology within this renewable energy ecosystem. It is the intelligence that connects energy generation, storage, and distribution into one integrated system. With that in mind, I'll hand it back to Jomil to conclude the presentation.
Renewable energy is more than just generating electricity. We need storage to manage the supply and demand, smart grids to move the electricity, and AI to help us coordinate the system. Together, these technologies can make renewable energy more reliable, more flexible, and resilient. From our group, thank you so much for listening.